All right, so part of Java versus Rust series, we are going to do an upload test today. We are going to upload a same size file to our to this file.io website. Obviously, we won't go to this website and upload a file, but we will programmatically call this URL to upload our file. And also, you can use this file.io website for your free file sharing, and I think it expires in 7 days or something. But yeah, this is where we'll target upload our files. Um, and So starting with Java first, I am using IntelliJ IDE, and for the Rust, I'm using the Rust Rover IDE. They are quite similar to what they do. Uh, But yeah, IntelliJ is quite ahead of Rust over IDE. I think it's because it's fairly new compared to IntelliJ. All right. So for the Java side of things, I will be using the closest to the JDK that I have installed. So I'm not going to use some external libraries to make an API call to upload a document. So I'll go with the native side of things, closer to the JDK that I installed. So java.net is what I will be using to make a HTTP request, build request, and all, and to read file and send it over. I'm just going to use the new file. All right. So what we are going to do first thing will be we'll start a timer. Um, it will be in nanoseconds. And I think down the line we are going to divide it by some thousand number, and then yeah, divided by 100,000. So let's see, and convert it to milliseconds. So the comparison is same. All right. So we are going to use the HTTP client to build our the HTTP client body using the new HTTP client builder we have. Um, this is very straightforward to build a HTTP client. Now, once we create the client, we will need to also make sure that we need to build a body, and also we are retrieving a file. So we are going to read this test file. So this test file is already created here, and it's a simple hello Java text here. So we are going to upload this file over to the file.io URL. Okay, so now we are going to construct a body. We are saying that, hey, I will be uploading a file as a form data. So it won't be the payload won't be a JSON or anything. Yeah, it will be a form data because that website takes it as a form data. And we are gonna give the key as file and then the file name itself, and uh, and then we are this file content that we read from the file path would be added into the request body, and then once we have the request body ready, we are going to send the the request over to this file.io website for us to upload a file. Okay. Yeah, so and then also that particular website requires us to have the content type as multi-part form data. So for this scenario, we really don't need to use multi-part. It can be just a regular upload with that bytes, the whole bytes itself. But let's say if you're uploading like 20, 30 MB, it's always good to go with the multi-part. All right, so let's see. Um, okay, so we already built the HTTP client. Now we build the request, right? So now we're gonna tell Java that, hey, Java, the request that I created, I want you to send that over. So now the sending part is when we'll use the client.send method they have. And I believe they have several other overloaded. Yeah, we have asynchronous. So I'm not going to use asynchronous here because On the Rust side of things, I am using a um, blocking one. So just to make it, just to make sure that the comparison is kind of closer, um, uh, I'm using the asynchronous send method from the client side. All right, so we're going to send this request, and after the request is received, we are going to calculate the total time it took. Now, then from the end to the start, we're gonna calculate get the difference of the time and get the total time it took to upload a file. So this is the Java side of things. Now moving on to the Rust. So if you go and look into this Rust, right, code here, um, it's in the Java side of things. I really didn't have to include or add any Maven dependency to do all this. Let's go to pom.xml. Um, yeah, it could be, yeah, these are for something else, but yeah, I really didn't have to like actually go and specifically tell that I want to add actually Java Neo. Yeah, I didn't see any extra that I added actually. Yeah, right. So pom.xml for Java side of things and cargo Toml, whatever, however you call it. This is equivalent to the pom.xml. This is where you're going to add your dependencies. And for our demo here, we are going to use request, a library here. Um, yeah, weird thing. Rust prefers to call it as library. Java prefers to call it as package. But regardless of that, it's same concept by the end of the day anyway. So we're saying that one good feature with Rust here compared to Java, the Maven is um, in Rust you can actually dictate the feature that you are trying to use, right? We are saying, hey, we will be using blocking feature, and then also we're going to upload it as a multi-part. All right. I imported TLS, but I don't think we're going to use that here. Um, Well, I think we will because the even though we are not importing our side of certificate, it's an open certificate on their end, so it will still be a HTTPS call, so it will be TLS. All right. Okay, so this is what we're importing here. Now going back to and this is going to be hello Ross. Same, the file size are almost same. Um, okay. All right. So now let's just for the comparison sake. So if I go to Java file, this is the main method in Java side of things, and uh, and then this notice here that we have IO exception throws and all right. So if you go back to Rust, well, we don't call it method, we call it function. So main function. Now we are saying that if any error were to happen, handle it here, exception handling way and then this tells you the result. So the result would be if it's failure, it will return the failure, and if it's successful, you'll see that. All right, so quite similar, observation on how Rust and Java they look like. But anyone who knows Java, I think it's very easy to learn Rust, and anyone who's learning Rust can easily get a hold of Java. There are obviously several other differences. Java runs on the JVM side of things. Rust, it's like closer to the machine, and maybe that's one of the reasons it's fast. At least from what I've seen, it's fast. I have personally done many runs like this. I started making videos like quite after, but I'm a fan of Rust at this point. I was a fan of Go, and then I thought it was faster and all. But yeah, this somehow I stumbled on this, and I think I'm loving it. But don't get me wrong, Java has its own strength though. It's older than Rust. If you are using any mission critical application, I would always go with the Java actually. Um, where the chances of getting any unknown bug needs to be zero, then I would go with Java because Java has been under the microscope for a long time, and there's so many patches there. Obviously, Rust is as well, but yeah. All right. Anyway, so yeah, so the first thing we're going to do is the same thing as we did on the Java side of things. So I could have used the instant here as well. I used the nano time here. But similar concept, instant now to get the actual time when the program runs. And we are going to use a file struct here. Same concept, it would be like public class file in Java, and but in Rust we call it as struct. And we're going to use the open function here. You can call it open method if you're like Java friendly, and we just set the path. And yeah, and let's see. So now, so the next thing is once we read a file, we are going to wrap that file with the multi-part part reader, and then you get the file name, and then store it here, and then this part would be read when we are sending via form. So all right, so this is the form that we are using because this is how it supports. Um, all right, so now we are saying we're going to send it as a part. We are going to create a new new instance of a form every time we do an upload. But for this demo, it would be one form getting uploaded because it's me, on a single instance on one laptop running also. All right, cool. So now we're going to create a client first. Same thing as going back to Java side of things, right? So if you go here, we are creating new HTTP client. Same concept, same process, just a different naming convention, right? So we're going to say let's client, and it's going to know that this is of type client object. So on the Java side, you would have to say HTTP client and then the client right here. On the Rust, you don't really have to. Rust is quite smart on this side of things that it will know, hey, this whatever lit client, right? We are saying we're client variable here. It will know that this is client. Okay, so now once we have the client created, we are going to post that. If you see the difference here, we're saying send and post. It's pretty much the same thing. Let's say if I were to use REST template here, I would be using post method, right? But since for this demo, we want to make things closer to their default settings. Okay, so we are going to send the request and get the total time it took to upload, and then get the time in milliseconds. Okay, cool. All right, so let's start with Java now. Let me send this file over. And what we'll do is we'll do like 5 to 7 runs and capture the time and and see what we see and see what we can analyze on the graph. So it took 1525 milliseconds on the Java side of uploads. Okay, I don't want to pay right now. Okay, so okay, 1525. Um, let's say milliseconds. Okay, that's the first run. First run is usually takes longer with the Java because it has to. Well, it's the same with the Rust as well. They have to make things ready. So 1486 milliseconds. All right. Let's go. Let's do a third run. And once again, we don't know how they behave differently. Let's see if I were to upload 300 MB. I'm not sure which performs well. But for this demo, we are uploading a document that's less than like 100 KB, 100 KB. Okay. Okay, 17, 16 milliseconds. All right, let's do one more. And also one thing to note here, right? So this does not dictate the performance on whatever the machine you are running. I'm showing this on my machine. It's a single instance running. It's a Windows machine. Things might behave different when they are running on the Linux side of things. Uh, 200 requests coming in versus one, but uh, take this as a stepping stone to understand the performance is what I would say. Okay, so let's see how many did I do? One, two, three, four, five, right? Let's go and run Rust now. Let's get some five more observation from Rust and the graph will tell us. Okay, it's compiling. Let's see. Oh, okay, it's 425 milliseconds. And yeah, I didn't like this though. Yeah, see, they are like by their yeah. I don't think we should be logging this, but regardless, well, if it's local, I think I'm certain there's a way to disable all this logging. But if this were to be running in production, yeah, I don't want this to be logged. Only log it when it's failing. But anyway, so 425 milliseconds. Oh wow, obviously you can see the difference here, right? Okay, all right. Deep down, I'm always rooting for Java to win, but yeah, let's see, 298 milliseconds. Let's do a third run, 310 milliseconds. Oops, where did I go? Okay, all right. Let's do a fourth run. And let's do a fifth run here. Okay. Yeah, I don't even have to tell who wins the race here on the upload side of things. All right, as you can see, once again, Rust is quite performant compared to Java when running on a single machine on a Windows laptop. Now, if we were to do a performance testing, and where we were to load 50,000, let's say, flows, we don't know how this graph will look. Hopefully, I will get some time to even do that demo, or somebody finds a way, or somebody might have already done it. Uh, they might behave differently when they do that kind of upload, stress testing, and all this. There's too many benchmark to consider. But for this demo, you can see the winner here. Rust once again takes the gold medal here. All right, cool. And once again, thank you for staying all the way to the end of this video. I will again bring a next series on Java versus Rust. Thank you.